I think we are live now. Yeah. I think we are live now. Yeah. Okay. Mm. So hey guys, hopefully you're doing fine. Um. So today, what I want to basically do is start working on type inferencing and then type checking for everything that I have right now. I did start type checking before, but I feel like it's kind of annoying the way I was doing, so I will be doing it in a different way. So actually, let me go in here and show you guys what I was doing. So in here we basically have type checking, right? And it's a giant loop, and it's going through the different types of nodes. But the thing is, in the middle of this type checking, I was also inferring types, which is kind of annoying because I'm mixing two things in the same step. And I know it's kind of efficient to do it like that, because then you already can say, okay, this is the type that we are expecting. This, I mean, not the type that we're expecting. This is the type that we got. This is the other type. Let's compare them. They match. Okay, that's fine. Otherwise, it's an error, whatever. But I don't want to do it like this because it's kind of annoying for me, at least right now. And it doesn't need to be very efficient right now. I don't want that to be the use case. Eventually I'll be rewriting everything in in chaos itself, so why bother optimizing if eventually I will just replace everything. So for the sake of making it easier for me, I will just split into two different steps. The first one would be type inferencing, and after we infer all the types that we need to infer, we are going to actually type check, and these are two different steps. And my eventual idea is that what I want the steps to be basically are: first we lex everything, we are lexing everything, then we are creating the AST, then we are doing the inference, we are inferring types. After that we are type checking. After the type checking, I want to create the intermediate representation and eventually do the code generation. The code generation for the language itself. And I don't feel like I should be including any optimizations or anything right now, because I will be rewriting everything eventually in itself, in the language itself, so I can do optimizations later. And there are probably other things that we could do in here. One of the things that I think I'll be doing later is that the AST will be like in a event generator of some sort, or a state machine or something, because I want to be able to basically have two different contexts. One is for runtime logic, and the other context would be compile time logic. And there's a whole bunch of things that I need to work to make it eventually be possible to have compile time evaluation. And I was basically thinking, but I will probably need to rewrite the AST here and how we are inferring and type checking. So let's see how it goes. But for now, I want to focus on these two steps, and then later in other streams we can basically look into intermediate representation and the code generation. And yeah, and after that obviously there is actually the binary. We generate the binary because from the code gen we can actually generate the binary that will eventually run in the program, but that's not something to be worried right now. So yeah, that's pretty much the idea. And before going forward, with the actual string. I just wanted to show you what I've been working on offline. Basically, I included a few things in here in the language itself. So the first thing that I did was include returns. So now we are able to return from functions, and only from functions. If it is outside of a function, it will just say that it's not expected, that's an error. So if I say return 0 or something and I try to compile it, default, it will just error out, be saying that return cannot be used outside of procedures, which we are in the global scope, so we are not allowed to do that. But everywhere else, if it is inside of a function, as you can see in here, this is a function, or here it's a function, it should be good to go, and we can compile it, and it should just work. Right now it is not compiling, of course, it is just generating the AST, but it is working, and I can even show you it is working, because if we take a look at the last exit code, it is 0, which means that it's okay. Otherwise, if we had something that is not expected, that it's an error, I can just return like 0. I can show you what it is like. You see it's 1, so we know it is working because it returns 0. So yeah, what else did I include? I think that's pretty much it, just returns. I don't remember if I included anything else. I don't think so. Yeah, I don't think I included anything other than that. I remember that I already mentioned about scopes and the keyword then, but other than that, I think that's pretty much it. So now let's start working on the type inferencing. So let's create a new file in here, and that would be like type inference or something. I guess that's as good of a name as I can think of. So inference, and then this is the package. This is the package main, I think. Let me see if I look into here. Yeah, so that should be fine. How I want to call it. So if I go to chaos, we have the content itself. So let's do maybe, I have no idea, chaos infer type or something. Types, I guess. I have no idea, but who cares? What I am expecting. I am basically expecting the slice that I got from here. So if I go in here, I know that I'm returning a few things, and one of the things that I want to change is that I'm returning the global scope in here, and instead of returning the access scope, we are basically just returning only the initial one, because that's the only one that we actually care. And then we have the program that will be type checking. So yeah, that seems fine. So let's get the actual nodes that we have to check. So let's go back into the type checking. So the type inferencing, I mean, we want this. We basically want the program. Now let's do the following. I think I'll start a little simpler than whatever I have right now. So let's look into main here, and I am going to just create a new file, I guess. So let's move main to main2 or whatever, and let's create a new file. And in here, what I basically want to do is simple assignments, I guess. So value 1, this is going to be 10. Value 2, this is going to be a string with something in here. And then we can have a boolean value, I don't know, value 3, it's true. That should be a good start, I guess. So what do we want to do? Let me go back to the AST, and I want to use the same construction, which is this one. And instead of tokens, so let me, so instead of tokens, it's program. Nope, this. If I actually type it correctly. So we have a program in here, and we are basically going to loop through nodes. And for that, let me do the following. If we go in here, we are basically not in here, but basically in here. This match. We are comparing tokens, and we are basically doing different. So instead of node type comparison, this is the one that I need. So let's go back. We need to do a match, so CS match. We are passing the program, we are passing this function, and then we are basically looking for, what are we looking for? Basically we are looking for what kind of nodes? Node identifiers, that would be my guess. So if we go into type inference, we need to get node identifiers. This is the first thing. So I just wanted to make sure that it is in fact working, and then we can basically just consume whatever. So we can just get or something, or consume, and then we pass the program. That should be fine. Let's see what happens. Default. It doesn't work because I never called this. So if we go into chaos, we are basically returning this, and we are calling this, and we need basically, I don't think we even need the depth, do we? And we also need a scope, which is basically a scope. And I think that should be fine. Do we need the depth? I don't think so. I don't think we need that. And one other thing that I probably can do, just for the sake of security, I guess, I can just assert something like the length of this access scope must be greater than 1. So the length of this needs to be at least greater or equal to 1. So this is basically impossible, I guess, but if it ever happens, we should fail. So access scope should never be less than 1. Otherwise there's a really weird error that I have no idea what happened between here and here. Something just crazy must have happened, so whatever. Now, since we don't have the depth, we can basically just pass the program, and we can pass the scope, and I don't think there's an error. Yes, and we don't return anything. I think that should be fine. So let's see what happens now. Okay, So we did find the identifier. Now things get very interesting. In which situation do we not infer type just by the identifier? I mean, one thing that we can, one thing that I know we'll eventually have is basically, instead of identifier, this is basically node proc definition. We can have something like this, but that's not how it's going to work. Because if you take a look in this right here, this is an assignment as well. So this is considered an identifier. You are basically assigning a function to this identifier. So everything is eventually identifier. So we are only inferring identifiers, right? Unless, yeah, so one other thing that I can think of that can be like a weird thing is like if we have 1 is less than 2 or something, and then we need to infer this, but technically that's, let's see how it goes. I don't know. Let's not go over things that we don't know. So if we match, we are basically getting yes, let's get this. We are getting the node, and I think that's just it. Yes, we are getting it by the, and I think we don't even need offset. No. So this is the node. Now the other thing that we probably need to do is check the variable declaration, because it is the node type, I guess, actually. So let's node the node type. This is the thing that we need to do, and I think we can even, don't I have the as a string? I thought I had something like that. Yeah, so this is it. I just wanted to know the type of this, and I mean it is identifier. So let's do the following. Let me just double check what we have in here. So this is identifier. Yeah, okay, I remember. I just trying to remember everything that I did before. So we know this is identifier, which means that we can just basically look into the variable declaration, and this is what we have as an identifier. Yes, and you can see here the symbol, you can see the type, we can see the assignment itself, and the assignment can be a bunch of different things. It can be integer, a string, or a boolean. I don't have floats for now. Later I can include them, but that's not important. But because I know it is identifier, that should be fine. I can just continue working with whatever I have in here. So we do have the node. If now we need to basically just go over all the different types of nodes that are available as an assignment, if I'm not mistaken. So an assignment is basically node type, so we need to go through them as well. So if node dot var declaration, var declaration, and then the node type itself, sorry, not it's the assignment dot node type, And then we need to basically go over all the different types of nodes in here. And in this case, but actually even before that, we need to double check what is the actual type of the thing. So if we take a look, it is saying boolean, but the thing is, it is getting this value during the creation of AST, and I don't want that to be a thing anymore, because that's kind of crazy, right? We are creating the AST, and at the same time we are inferring the type, which is kind of weird. So I don't want that to be the case anymore. So basically there's something like I infer or something, infer type. So in here I need to remove this. Basically this is no longer a thing that exists. So let me go back. So let me take a look. So in here we are parsing the identifier. We are doing token infer. So it's basically just removing this. And that should be fine. It's still fine. Yes. Because we're no longer inferring anything. And then the token type is 31. So that should be good to go. And then we already know. So let's go into this right here. We are basically removing this because that doesn't work anymore. And then we can go into chaos type checking, type inferencing actually. And we basically need to do whatever I was doing here, but in here. So if we don't get, that's the first thing. If we don't get, if we don't have a, so after the node, if node type, not the node type, this is the variable declaration, I guess. Variable declaration dot type dot token type. It's not, if it is not token infer, we are basically skipping it, I guess. We can basically just continue and we can basically consume whatever we get in here from the program, because we don't really care. Now we do know it is token inferring here, and we basically need to do some crazy things actually. And let me see something. It returns as a value. That's kind of annoying. Can I have one version of this that is get by pointer? So we can can we just say this is a pointer to a node? What is the error? What? I see. Can I then fuck that? Yeah, no, the thing is, it is returning whatever I passing. So yeah, I need to create a version that is basically returned by pointer, I guess. So we can just say like get pointer or something. And this is any, sure. And then we can just pass the slice. And that needs to be by pointers. Okay, slice using T. that is a pointer, and we are basic, yeah, so I need to pass the offset as well. And then we need to return the pointer for that thing, and we need to basically do this, but instead of doing things like that, I need to do a little bit differently. I can just return this, I guess. What? Where am I? What? Here. And I need to return that as a pointer, I guess. Cannot use okay. How can I do that? Because one other thing that I can probably do then, instead of getting, is just sure, whatever. That's kind of annoying, I guess. Oh man, I don't want to get a value. It is returning as a value, so if I change it, it doesn't change in the slice, so it's kind of annoying. Fuck me. So it's not possible. I mean, it should be, right? Yeah, I think that is the correct approach, actually. I was just doing it wrong because I was passing it, but it is already a pointer, I guess. So yeah, okay, that's fine. So let's get this, let's go back to this, and then instead of this, we get this. What is the problem in here? But oh yeah, so here we can still keep this as like this. And what is the problem? And now, okay, I see, now we can do it like this. Yeah, okay, that's what was the problem. So we got the node as a pointer. Now whatever I do in here is okay, because it is in fact a pointer. I can change things and it will be reflected in the slice. And I can even double check it just to make sure it is in fact correct. So if I do like debug and I print the node variable declaration, and then basically I do var declaration, I don't know, name, I can say something different, I can say some whatever, we can double check it is in fact different. So it is in fact, is it different? Yes. So it is weird because I'm printing it. So let me do the following. Instead of doing that, I will print a program. And after that I will just break, because I just want to print it once. Huh? Why though? It is not. Huh? Is it because it's oh, sorry, what? Did I do a fucking... No, I don't know what the hell is happening here. Whatever, I know that probably it is going to work. I don't care. If it is an error later, I can fix it. Whatever, I do something else. That is not what I want to do, but okay. Anyway, so we can get the node, variable declaration, now the assignment. I want to get the so one thing, right? Variable declaration, and I want to get the assignment of that thing, and then I need to know after the assignment if it is a string literal, the assignment, the node type of that thing, and if that thing is a node int literal or something, fuck, int, why, what is happening? Huh? Fucking Neovin, I hate it. Okay, so if it is like this, we are basically just, we basically know that the actual type of the node is S64, because this is the default type for numbers. So let me just double check that we got the correct thing, and it is in fact a number. It is in fact a number, value 10, so yeah, and this is in fact what I had, if I'm not mistaken. It is 10. Okay, so if we find it, we are just changing the value here, right? So we are saying that the node variable declaration the type of it is basically sin64, which is using this function right here, and that's pretty much it. Then we can basically consume it and move on. And eventually I think I should separate this into different functions, but for now let's do this as a loop that I think it's a little bit easier. So the other thing is, if it is not a integer, so it is probably a string literal, and then we can just say, okay, instead of that, do that string, then we consume. Otherwise, let's move on, and instead of string literal, it's a boolean literal, and then we can say it's a bool, and that should be it. And we don't need to consume anything in here because we consumed everything. And it is in fact working, and we can even basically just print later chaos program. So yeah, I think it's a weird behavior in here because it is in fact not a pointer, but it thinks it is a pointer. So one thing that I can probably do is just data, and then we can just remove this. Yeah. So what we have in here, value 3, it's a boolean, and we can double check it is in fact a boolean. In here we have a string, and we can in fact see this is it's a string, and this right here is a number, and in fact it is a number. So nice. Yeah, okay. The other thing, but I don't think I'll be doing it now because it is a lot more complicated and I want it to be. I basically want to infer the type from a function. So if we take a look at this right here, as I said, this is a anonymous function and we are technically inferring, but in here we have it's a function that doesn't have anything as input and returns a boolean. So this is the type of the function. But the thing is, I don't know if I really want to do it like this, because there is a nice feeling of having the signature of the function being the actual type that we can use for something, instead of having something that is a weird, like this is a proc and we have an input, we have a bunch of inputs like an array or something. What is happening? We have an array of whatever, and then we have another array of whatever in here, that is the output. And then we also would have to have generics eventually, and it's like, what the fuck is this? It is insane to have something like this. If you do it like this, you are crazy. And I don't even feel like generics should be part of the signature. As far as I have considered, generics are part of the actual assignment. So if we have a, this is part of the identifier, not the type, you know. So I'll probably just skip it for now. I think that is better. We can just skip and later we can think about it, but right now I don't really I don't want to do it. So now I think I want to split this, make this its own function. So infer, I can do something like infer literals or something. Infer literals, and we are basically returning nothing. We can just return boolean, I guess. I mean, I don't think we even need that. We can just move on. So we do everything here. We are just doing like this, and then we need to get the node, which is basically a pointer to whatever. That's the thing. We can even probably, so we can do the following. Let's return a boolean, and if we find it, we can just return true. In here, actually it's false, right? If it is a token type, we just move on. Or I mean, it is true as well, I guess. If it is an infer, we can just move on, and that's life. So the thing is, now that I'm thinking about it, we are always doing it. So because what I want to do, so let's think about it. So I want to get this, and I want to do it like this, and I want to pass the node in here, and if we have true, we are basically consuming, so we consume not check bounds, we consume the program, and then we just continue. That's what I want to do. Otherwise, I don't need to do anything. I just consume and continue. So we don't need anything. So we can just move on, I guess. And I mean, it's an early return, I guess, because most of them will be tokening for, so most of them will not be tokening for, I guess, so that's okay. It's just an early return, so sure, let's do it like this. Just return. And the same in here. Otherwise, we can just return. I mean, it doesn't make any sense, so whatever. It is kind of weird, I think, actually. But, you know, who cares? Either way, we are consuming and returning, so whatever. Sure. Is it though? Whatever, I don't know. I can think about it later. Let's think about it later. Now, the other thing that we probably need to think about is, instead of having literals, so let's look into main, not this. So instead of having literals, we need to think about other identifiers. So for instance, if we have like value 4 is equal to value 1, or if we have value 5 is equal to value 2, I guess, and value 6 is equal to value 3. Basically, we need to do it like this. We need to be able to handle different types given the identifier. We are basically inferring from this. And that's where we have scopes, because in here we don't really care about scopes, because, you know, why care about the scopes if we already know the literal? But now we do care about scopes because yeah, we do care about scopes. Because we need to check for them in here. So we need to be aware of value 1, basically. So how can we actually do that? So we still need to look into the identifiers in here. Yeah, okay, so that's one thing that is kind of annoying that I think we will have to change. So yeah, let's do it like that then. Instead of nodes, we are actually accepting the entire program as a pointer, right? So chaos slice, and we are passing the nodes. Then we need to create a node from that, and we are basically getting this from the program, and this needs to be by pointer, get pointer. And in fact we do need to return something, I guess, maybe. I don't know, yeah, whatever. So here we have a program. We don't need this, probably we need this. Then we are basically consuming, we consume the program and we move on. And then we can basically say it's a boolean, I guess, and we can return false, right? I don't know, either way. Then we can do the same thing here and then the same thing there. We can do it like here, fuck me, do it like this and then like this, and then we can just do this. So what I want to do, I think what I want to do is, if not, so here is like yeah, this is super fucking annoying actually. Whatever, because the thing is, eventually we what I want to do is, let's keep it like that for now, because I don't know how it's going to look like, but whatever. If we have basically a node in here, we get the pointer for the program for the current node. What the fuck? This is the node. If this node variable declaration dot assignment dot node type is equal to node identifier, we need to do some crazy shit. I feel like this can be improved drastically actually. Because later what I basically want, so this is parse literals, and parse literals is basically the most basic thing ever, so it should return always true or false, and if it is false there's an error. So this probably shouldn't even be in here, this token infer, it should be probably be in here before everything else, and then we have it like this, and instead of return we just continue because we basically don't care. Now we are inferring it, so we need to basically say if this is true, if this is not true, there is an error, so we can basically return a boolean. And I think that's actually a better approach. Return true, true, and true. Otherwise return false because there is an error. Yes, so if it is not true we can basically get the result, and basically if not result we basically assert false, or we assert the result which is false. So we assert this and you can just say could not infer the type of a literal. And then one of the things that we can basically do is importing FMT, and we can improve this error message. So FMT as printf. So we are saying, okay, we could not do this because we got a weird thing that we were not expecting. Could not infer the type of the literal, and then we can just say the literal that we tried, I guess. And since we never consumed anything because it was an error, right? It reached in here. I can just get that. Could not get the type of the literal, whatever. And I can just get from this. And then we can just no type. And we can basically just have it like this. From the literal type, whatever. Because eventually maybe we have something a little bit different. Maybe we have something that is not boolean, string, or a number. Maybe it's a float. Maybe it's a struct literal or something. I don't know. Either way, it should fail. And we are asserting it is in fact a failure. Now, if it is in fact identifier, as we have in this example right here, then we can it is going to basically continue, I guess. Yeah, because yeah, that's super annoying actually. Another thing that I can do, which I think it's actually a lot better. What the fuck? What? Huh? What was that? Weird. Okay, so anyway, I can basically just have it like in here. And instead of return any, I bring return a boolean, and we are basically asserting false. And we don't even need this right here. I can just get the node itself because we already have it. And it's a lot better, I guess. No, actually, fuck me in the ass. I really hate it. I really hate this. Yes. Yeah, whatever. Let's not do this then. In fact, I will not do this right now. I will do it later. I cannot think of a better way, and I don't want to waste time on this. So fuck this. We basically need to do this. We can remove this. If we get this, we can do this, and then this. Whatever. I don't care. I don't want to think about it. That's the easiest way to do it. Fuck this. Otherwise, we are basically replicating. So in here, we need to. What do we have in here? Edit it anyways. later I can just delete this, whatever. So whatever. Let's see. Why are you doing this to me? Fuck this. So value 6 is equal to value 3, and basically we need to now access the scope to check for this specific thing. So how can we do that? So this is the right hand side, I guess. The right hand side is basically whatever we get in here, and I know it is an identifier, which means it's a variable declaration, and I know it has a name, which is also a symbol. And one of the things that I can basically do is look how I'm doing it in here, because I need to do it somewhere here, I don't remember where. In the check identifier in scope, this is basically it. It's a little bit different because I'm not looking throughout the scopes, I'm only looking on the current global scope. Which begs the question, do I need access to other scopes later? I mean, probably. Kind of annoying, but not really, because we do have access to other scopes later. Yeah, whatever. So we need to look into the current scope, and we are basically just looking, comparing symbols, and that's it. Yeah, that's fine. So let's do the following for whatever, and then n, I guess, and we are looking through the scope, and this is a range. If we have right hand side, and we can even do something like this, is equal to n dot name dot symbol, var declaration name symbol, it means that it's okay. It means that we found it, which means that we can basically get the type from that thing. And then what we can do is, can we pass this as a pointer as well? That should be fine. What is the problem? And then can I dereference this? I mean this. That should be fine, but the actual thing is a pointer, so that should be okay. So I can basically get this, which actually, instead of getting the symbol, we can get the actual variable declaration, and then we can just we can get these, the right hand side. The name, what is what? Why it is not working? I don't get it. Huh? Is it because No, I don't get it. What? Right hand side dot name. Why? Can't I just do it like this? I need to dereference this? That's fucking annoying and cursed, I guess. But whatever, I hate this language. Var declaration name symbol. Why are you like this? Why are you like this? Because this... So this is actually already a thing. Yeah. Dot type dot, and I can just do this var declaration name type, and that should be fine, and then we can just break it. Yeah. And that should be probably it. Let me remove this because I don't care. Let's run this. So this is in fact a boolean, this is in fact a string, and this is in fact a signed 64. And one other thing that I can probably do, I guess, how can I do that? Just for the sake of better error handling. I mean, do we need it? Because if I don't, so if I don't do it like this, let's say this is not a thing, it is going to fail anyway because there's no symbol. So it should just work. Yeah. And we can also do it like this, I guess, and that would be between for. Yes. So yeah, that is fine. Is there anything else that we would need to actually consider? Do we need to continue here? I don't think so. It is going to continue either way. Yeah, we are covering basically everything. So the thing is, if it is in here, there's something that we didn't check, so we can just assert false. Gots, and I will need back this. I fucking hate this language because I need to keep deleting things. It's annoying. So fmts printf unexpected value, unexpected node, I guess, node type, and then we just pass the node type, which we can't even pass it in here because here is the actual loop. Yes, so we can just get. And just for the sake of making it easier, we can just say node, and then we can say node to string, and this is the node. What it doesn't like. Yeah. Which is kind of cool. I don't think we have any problems. It should be working okay. Let me just fucking destroy that. Now, what if I move this main to main3.go.chaos and then I revert main2 to main? Will that work? Unexpected node identifier. Huh. Interesting. Where? I see. This right here, I guess, maybe. So the case where we have so let's do the following. Should do actually handle type inference for functions. For now, I don't really know what I want. Skipping it. So if we find basically a proc definition, we just whatever go on. Now, one interesting thing is function calls that we can infer. That is actually kind of something that we can do. But let me do it like this: proc def. If we find it, we are just skipping it. That's okay. We can even probably just put a warning message, I guess. So fmt fprintf. I mean, I don't need fprintf, just printf, I guess. Warning, skipping type inferencing for proc definition. And I think that's fine. That should be fine. It's still going to fail. Yes, on node call. But this one, we can actually do something about it. So if we find it, we already know it because it is in the scope, and that is instead of this, it's call. Why are you like this? Why are you like this? So in here we need to basically do this that we have in here, the same behavior. It doesn't change at all, but instead we let me see what we have as a call. We have inputs, the arity, but we do have the name. We need to check on the scope. So basically the same thing that we have in here. So this is the right hand side, same behavior. This is the variable declaration, but instead of variable declaration, it's a call. This is the call. And then we need to loop the scope to find this and do this exact same thing, but instead of assigning, it is different, the behavior that we want. So once we find this, instead of not variable declaration, we know. So what we want in here, we are looking for the call name symbol, and if they do match, what I need to do is not even the call, it is actually the definition. So this is proc definition. Yes. So is it though? So proc, yes it is. Then proc that's annoying as hell. We just need the identifier. So it is in fact var declaration. And if we find it, we basically have everything else then, if they match. For the sake of whatever, let's do this. Chaos debug, I want to know what is n. Didn't I just do this? What do you mean? Huh? Node call. Oh, I see what you mean. Yeah, this is kind of annoying actually, because you see, it is failing in this specific location because this is a statement, but this, so something here acts as a statement, but if I do like whatever, something is an expression. That's why. And I need to handle it in two different ways. So if it is in fact, so let's do the following. So outside of this, if we find, we can even do something a little bit different. If it is not this, just continue, just consume and continue. And then we can make our lives a little bit easier. So if it is not an identifier, I don't fucking care. Let's see what happens now. Okay. It failed in a very weird place. That I'm not sure where. Is it in here? What happens if I don't have it like this? Still failing. On memory. Fucking new memory. I know the reference, I guess. We are not even reaching, are we? So can I just, what happens like this? I'm sorry. What do you mean? It hangs? Why? It hangs? That's not great. Because I mean, that's the problem. Hopefully, yes. Okay, so we do reach where we need to reach. And the problem is because there's a weird thing that I did in here that's the no reference. Yes. Now, why? This is the fucking problem. Let's not. So if we do what is an it's so fucking annoying. I hate it. I hate this language. It's fucking trash. Ugh. So we have quite a lot of things for some reason. Why we have so many things? Oh yeah, because sure, whatever. The wrong file. I'm thinking of something else. Sure. So basically I need to get the right hand side, and the right hand side is basically this. So if I take a look at the main, if I go to something else, in here, yeah, that's the actual problem that I need to eventually fix. Maybe. No, I don't even need to fix it later. I can do it right now. So this is something else. And we basically need to look for why. We need to look for that same symbol. So I need to basically check for the right hand side name symbol that matches the identifier variable declaration.name.symbol. Technically, only if this right here is an identifier. Node type is equal to node identifier, and then we can do this. That should be okay. Yes, so we can even double check that we reached. Reached. Yes, in fact, it did reach. Now we have it. We have everything, and we know everything. We need to basically do node variable declaration dot type will be the same as name the node variable declaration. No. Yes. Var declaration dot assignment dot proc dot outputs. It's a bunch of nodes, but for now we are only accepting one. Then we can just get the actual So how can we actually do this? That's annoying. Because what are we doing? So let's go to proc definition. Open parent, close parent, arrow. So return type is another variable declaration. So we need to check for that. Variable declaration type name. And one other thing that we need to do in here for now, later we need to fix it because, you know, we need assert any, basically that the length of this is equal to 1 and we don't have any other value in here. Why are you like this? I don't know. Cannot have returns, multiple returns for now. And then basically we can break and then that's it. We consume and continue. Cannot have multiple returns. Must be less than or equal to 1. That's probably something less than or equal to, or I mean false. If it is false, it means it is less than or equal to this. It's okay, otherwise it's false. So okay. In another thing that is very important is if we don't have anything, so let's do like this: returns length is this, and return length is equal to 0. Is not equal to 0, we do it like this, otherwise there's nothing for us to infer. Which in fact doesn't make any sense. And that's a whole other issue that I need to eventually fix, but whatever. So let's keep it like this. Yeah, that's what I was expecting. So where did you fail actually? Yeah, so let's do the following. In the AST, in the proc definition, we need to do something a little bit different in here. So in here, we consume assert if we have an arrow. If we don't have an arrow, we basically have void. So what we can basically do here is the following. I can just have an else branch for now, because in this case we need to create a bunch of things. So let's get everything in here. Is not the return type, there is no such a thing. This is make a type, because in here we specifically need to set the type, and it's void. If I'm not mistaken, it returns a token, and we are in fact expecting a token. So yeah, it is identifier, this is void, is initialized no, there's nothing else, that should be fine. Just for the sake of example, let me show how it actually looks like. So if we don't have anything in here, it is a void, basically don't have a return. But since we have an arrow, we have a return, that should be a return type of the thing that of the function. So let's go into the inferencing. So if it is not equal to 0, it means that we are assigning something in here, and that should be fine. Now, why are you complaining? That's something that I don't know. But one thing that we can in fact do is see the actual node. So something else, and the type is void, because technically something else doesn't have a type, I guess. So let's take a look. Something else, in fact it doesn't, but if we say something like a string, and we can say that this is in here, and we are returning a string. Not that there is anything for strings right now, but who cares? I just wanted to see if it is in fact working. It should be something different. It is in fact a string. It is working. Now, why are you complaining about something else? What are you complaining about? Is it this? No. So I can just remove this. So what is the problem in here? Let's basically look. Something else is working. So this right here, is this right here the problem? For whatever reason, it is in fact something there. Yeah, so is this the problem? It isn't. Is this the problem? It isn't. It's specifically this. It is. So yeah, this is gonna be a bit annoying actually, because we need to basically infer the type of every single node in here, and we need to traverse a tree. But if I do something like 64, it should work. That's my guess. Yeah, that's annoying as hell. So just for you guys to know what is actually happening here. So let me save this. Let me go back to the actual chaos AST. And then if we go to pret parsing, I think that's parsing. Where is it? I don't remember the name. Yeah, so I'm calling this base node. In here, I am literally parsing the nodes parse expression. I mean, this is here actually parse expression. The base nodes are just the individual nodes that don't have anything, but the expression in here is what I'm doing. So this right here, this is in the entire expression. Not only this, but also this is an expression, this is considered expression, you know, this is expression, everything that I showed is an expression. Here is how we do it. We basically get a base node, which basically is like 10. 10 is a base node, or something else is a base node, or this value is a base node, or this right here is technically a base node, maybe. So yeah, technically not, but I mean kind of is, but whatever. We create a base node. If we have a open parent, we are basically doing something a little bit different, because we need to account for parsing parentheses. And then while it is true, we have different operations, and each operation has a different precedence. And we are basically saying, okay, use this operation. If we find the operation, sure, that's nice and great. We can continue the parsing of the expression. Otherwise, we basically break because we didn't find an operation, which means that this is not a expression. There's something else that is happening. We then consume, and then we need to get the infix power, which basically defines how we are associating different operators. So depending on the type of operator, it is more likely to go one direction over the other. Something like if we have 1 plus 2, basically each of these are a node, and then we can say minus 1, just for the sake of example. When we are parsing, we are basically trying to group things and to make sure that we have the same behavior over and over. We have two different weights that goes between the two operators. So for instance, in here we have, in here is one weight, and in here is another, and depending on the weight it is associated differently. Meaning in here we are saying that 1 has a weight of 1, so on the right side, on the left side, I mean this side right here, it has a weight of 1.0, meaning that it can only go here because there's nothing after it, so there's nothing in here in this space. But the 2 is more likely to go to the other side because they have the same precedence as plus, but because they have the same precedence, we're basically saying, okay, 2 is more likely to go to the right. It has a right-sided bias or something. So at the end we have 1, not like this, we have 1 plus 2 minus 1, because the 2 is has a bias, not likely, has a full bias to go towards minus. So yeah, we do this to define the precedence of things. Once they are defined, basically we continue. This is because, you know, float operations almost equal, otherwise it is never working. And then we parse the expression again, and we do that over and over. And once we break in here or in here, basically we just return the result. So we need to do something like this for type inferencing, but for all the values that we are passing here, and that's kind of annoying because we can mix and match different types of things. So we can have literals, we can have identifiers, we can have function calls, and they all should work similarly. So yeah, that's kind of annoying, and I don't think I want to do it right now. Maybe. Yeah, let me think about it. Is it much work? I mean, maybe not. Maybe it is, I guess. I don't know. Let me see what we have in here. The one thing that I am 100% sure that I need to do is split these things into different functions, because then later it is easier for me to call things. So I kind of want to simplify whatever we have in here, because these right here, they are pretty much the same shit. And then we have identifiers, and then we have function calls. Yeah, let me think about it. I will do a small break because I need to use the bathroom. Just maybe like 15 minutes or something. So, quick break. Be right back. So yeah, be right back. Hey, hello, I'm back. Um, so I think that instead of focusing on type checking, edit anyway, whatever. Instead of type checking this, I think I'll just move on. I mean, not type check, but infer the type. I will move on and work on type checking because I think it's more interesting to work on that. And later I can just work on it by myself because it's kind of annoying and I need to waste a lot of time thinking on how I want to do that, and I don't want to do it right now. So yes, basically now I want to work on type checking, and this is more interesting than whatever I am doing right now. So most of the things in here I think can just probably be gone. Probably. So not everything, a few things actually. So let me go back in here, infer types, and then type check. And I even think I will change the name to chaos type check. I think it makes more sense. So in here is basically the same thing. I don't need the scope, I don't need depth. I just need, yes, I just need the global scope and everything else should be fine. So yeah, that's a lot of things that I don't care about, I guess. Let me just delete everything in here because I do have everything in GitHub, so if I need to I can just go back. Not even GitHub, but I have everything inside of Git. So something very important actually, I need to when we are actually type checking or type inferring, edit anyway, after that we basically need to get the program counter to 0, cursor to 0, because now we finished the inferencing, which means that now we are ready to do it. Like, and I can even, let me go back, sorry, not this, let me even go back, and I need this in here as well, just for the sake of security, I guess. Maybe I forget something later on and there's an issue, whatever. So yeah, so this is the type check. The first thing that we are doing is checking for a node identifier. If we find a node identifier, there's a bunch of things that we can do. And the first thing, and in here we don't need the scopes anymore, we don't need the depth anymore because we never used it, if I'm not mistaken. We can just pass the global scope, and that will be the default behavior for, not default behavior, that will be what we need to look into for most of things. If we are talking about procs, functions, whatever, then we need to use the scopes inside of the functions, and that's a whole another story. So now very important. Let me then move back main to main2.chaos and then main3 to main.chaos, just to make our lives easier. And that is in fact working. So if we take a look in here, we do have the things that we were talking about, and then we can start working on new things, so new value. And this new value is basically S64, and we are saying that this is value 1. So this is the first thing, and I think this should still work. No, it doesn't actually. So the identifier new value expected type 64 but got something different. So variable type var declaration type so why you didn't like it? What do we have in here? What is the type for this S64? Oh yeah, so now comes the actual, so we need to check scopes and no longer we need to do this weird thing that I was doing before, because we don't actually have access to that. We just know that it's an identifier. So this is the symbol. We don't have any assignment in here. That would be my guess. But why is it thinking it's a literal? So identifier signed 64 but got something else. What do you mean? This is the value. Why though? It is signed 64. Huh? New value. Yeah, so value 1 worked. Yeah, so this is the literal actually, so that's why. Let's go back. It's in here that is the problem. So we have the identifier in here. I don't know if I want this. I think I'll just remove this for now. Later I can go back. And now, instead of doing whatever the fuck I was doing before, I need to actually do, I need to look into the scope. Yeah, so this right here doesn't actually work anymore. And we need to loop through the actual scope, so whatever we get in here, it's actually in this. And then we can do a range over the node, or not even the node, the scope that is currently available for this. And we need to check specifically for this right here, token type, right? And not even token type in here, because we already inferred whatever we had before. Yeah, so this actually doesn't, That's not a thing. If this variable declaration type dot symbol is equal to what I want in here actually is, wait a second, left hand side. Yeah, so I'm matching types in here. Okay, so this technically would be, this is new value. I'm getting the type for this, which is S64. Okay, and then I need to get the assignment. So this is the identifier. So left hand side identifier, this is the first thing that we have, which technically is useless. We don't really care about it, but sure, we can use that for error messages. And then we have the var type for that. And then we have right hand side identifier, which is basically var declaration. Dot assignment dot var declaration again, because we know it is an assignment. And then we can basically get this symbol, and this is the right hand side. Now we basically need this right hand side in here to match whatever we have in the scope, which is first thing we need to say is that this is a node type is equal to node identifier, and after that we need to get the variable declaration name symbol, and then we are good to go. Yeah. Now that we have found it, we need to basically compare the, no, we can even do something like this. We have the right hand side variable type, and by default we have something like here, and this is a token, I guess. Because this is a token, yes. So this is an empty token, and then if we found it, basically we need to assign the node type, which is a variable declaration type, and that should be fine, and then it should work. Let's see. Not used. What do you mean not used? It is used. Line 70. What do you, oh yeah, okay. So in here we need to do this. So yeah, value 4. Value 4 expected whatever, but got whatever. What do you mean? So for now, let me just focus on the one thing. It is in fact working. Nice. And if it is something different, so we can say value 2, it is an error. Expected S64 but got string, sure. And the same goes for boolean. Yes. Now, why is it failing specifically here now? Because technically it is correct, right? So it should be matching. In fact, it feels like it doesn't understand on the inferencing. So let's take a look. If it is identifier, what is the node actually? So this is value 4. It doesn't work. Why? Isn't this like a pointer? Sorry, not here. Here. Because node is a pointer. I fucking hate this. Do I need to do something like this? The reference and then get the pointer back? No, I don't get this. No. So this is a pointer. What do you mean? I mean, if you want me to be as annoying as fuck, sure. But I mean, it still doesn't work. Why? That's so fucking annoying. Are you really saying that I... What is this? It is S64. But it's not assigning that correctly. Why? If this is a pointer, which I assume it is, why is not working? It is a pointer, not a fucking value, whatever. We can even double check that. Printf. I want to know the actual type of this. Yeah, this is a fucking pointer to a variable declaration. And if I do it like this, it is a token. Do I need to explicitly do it like this to make it a pointer? Can I do it like this then? I need this to be a pointer. Huh? What is the actual problem here? I don't get it. Do I need to do something cursed like this? No. That's what I thought. What? Oh my fucking... Do you really want me to do this the fucking annoying ass way? Man, that's so fucking cursed. You try to do it like a looking good, but then I mean there's no way, right? You want me to do it like this? Yeah, I have no idea how. Because what I think, what I would like to do is like this. Let's use C as an example. If I have something like int whatever, fucking char whatever, and then we have identifier in here, and then I have a pointer to a pointer. And then we have basically a whatever. We have a, this is just pseudocode. This doesn't actually what I want to do. And then we have something like this. If I do identifier at this position, basically we're getting a pointer to this string right here, which means that this is basically sharp pointer to whatever, right? Which means that if I change something to whatever at this address, it should still work, because this is a pointer. It's a pointer to something. And this is basically what I want to do in here. And node is a pointer because we are getting that as a pointer. So this is a pointer. But it doesn't work like that, I guess, because fuck you. That is crazy, actually. There's no way it doesn't work. It works like this. Can't I just do it like... How can I do that? Really. And the thing is, even if I do it like this, it doesn't fucking work because fuck me. If you take a look, it doesn't work. Why? I don't know. Node is a pointer, which means that instead of using this fucking annoying as whatever, I need to do it like this, which is fucking cursed. And instead I need to do it like this. Instead of this, it's program. No? What? What do you mean? Wait a minute. Is not the assignment, is the actual fucking type in here. Is that the problem? Is that the problem? No, it isn't. Fuck. No, it is still failing. So in the variable declaration, we need a type. And this is exactly what the fuck we're doing. Why? Unless you want me to do that fucking disgusting thing where I just need to get this and update this directly in here, which is fucking cursed. And then we can just remove this and have program. No, it doesn't work either. Why? I don't get it. I simply don't get it. Fuck. What is this? Let's see. Why though? Why? Why it is not saving? it is supposed to be saving. It is a token. That's disgusting. I hate this language. It's fucking garbage. So in here it works. I want to just print. Just print everything after. Just give me everything. That fucking piece of shit. Value 1 S64. Okay. Value 1. Why? Wait a minute. Why do we have value 1 twice? Save this, fuck everything else. Remove this, run again. Value 1 is S64. Why there's 2? Type inference. Edit anyway. Okay. That's fucking why. Value 1 is this. Value 2 is a string, sure. Value 3 is a boolean, sure. Okay, now if we go back and we enable this, run this, value 4, it should be. Why though? Why? What the fuck? Why this? Is it because we don't update the scope? Nah. Okay. So for whatever, we have a range over this fucking scope that I need to fucking update this scope as well, because we eventually have to do the lookup for that. Need to take a very deep breath, otherwise I will just explode my brains off. So if the end dot variable declaration name symbol, and we need to be sure that this is a identifier. I mean, we know it is identifier in here, so we can just move on. Is equal to whatever we have in here. If we have this, basically we need to dereference this, and then we need to assign whatever dot var declaration dot type is equal to this. No, it doesn't fucking work as well. Do I need to dereference this? No, it doesn't fucking work. That's how the hell do I do this? Index. Fuck. Screw this fucking piece of fucking whatever shit. Scope at this index is equal to var_decla.type is this. Let's directly change this, and then we can just fucking break. Let's remove this result. No, it doesn't work. Just remove this result, whatever. Assign 64. Assign 64. Why do we have two of them if I fucking removed everything? I think I just killed myself. That's value 4. Don't have any fucking thing. So this is scope at 0 position. It is in fact why it is appearing twice in the scope, when in fact it should be only once. What? What is this? One. No, I don't get it. Are we doing something wrong here? Because there's no way it should be appearing twice. So we are parsing the fucking statement. It is not a scope. It is an identifier. So we are parsing the fucking expression. It is not end of file. So if we find token identifier and assignment, we are doing something, we are not. Let's go to the next one. It is a column. We are consuming it. We are saying it's identifier. We are saying it is true. We are creating the variable declaration. And we are saying that we need to infer that and it's not initialized. If we find identifier, we do something, it is not identifier, so fuck that. Because actually, what? It's if we have identifier in column, if we have another identifier, yeah, okay. If we do have identifier, we do this. And we need to do this inside of here actually. What the fuck? What is happening? Why are you doing things fucking wrong? So this needs to be inside of here, because if it is in here, we are only checking for it inside. Otherwise it doesn't make any sense. Because we cannot. So, else we have an error. So here should be an error. Cert false. Should have identifier. So if it is not identifier, if I semicolon, it's an error. No. The error is only in here. No, it isn't. Just here. Okay, sure. So we have assignment. If it is assignment, we are saying it is initialized, in fact. If it is then we do this. If it is a proc, we're doing something different, otherwise we move on. We are parsing the expression. So do we have more than one appending here? No, because in here we just return. In here move on, parse expression again. We don't do anything in here, we are parsing expression, sure. Do we do anything in here? Only if it is a call. But this is not related. That is annoying as fuck. Because we shouldn't have ever two values in here. It doesn't make any sense. Value 1. Value 1 again. Why? Value 2. Value 2. Why is it duplicated? Why? What the fuck is this? Are we doing anything here that is weird? No. Actually, one thing that we can probably do is append only in this case, otherwise let's see if that helps. 1 1 no 2 2. That doesn't fucking help. It doesn't make any fucking sense. If we have another column, here appending, but this is only if it is a proc, so whatever, otherwise move on. Should we be doing this later? For no, it doesn't really fucking matter. Oh man. I have no idea what the fuck. What the fuck? What the fuck? What is this? Why are we repeating things? What I think I need to do actually is not use append, and in fact I do something different when we are talking about scopes. What I think I need to do is probably I need to check if something exists and update the thing that exists there, otherwise append the new thing, to avoid this fucking kind of annoying issues that I'm having right now, that I want to die. I want to jump off a bridge or something right now, because it's annoying, and it took me by surprise, and it is such a... Let me drink some water. So let me do the following. Let's first do this. Let me include this. Git status, git checkout, type inference, introducing type inference, and then basically I need to include chaos, git add chaos.go, chaos slice, chaos type checking, no, type inference, and what else? Git diff. What do we have in here that is different? Yeah, I think that's about it. So let's git status, git add chaos ast, and then what did I change in the utils? Probably, yeah, just that, sure. I can just git restore chaos utils. So git commit introducing type inference step just for now, because that's, I think that's okay, that should be okay. Let me check. Sure. Yes, I do already have the PR for that. Let me check something, because that's annoying and I want to make sure it is actually a thing that can happen. So let me go into maybe like make dir temp or whatever. Actually, I learned about something recently that is kind of nice. I don't know if people know about it. I can just do something like this, and then I can just go into here, and later it will be deleted, and I can do whatever I want in here. So main.go, main, let's do package main. So we have func main, and what I want to do is basically the following. Let's have a variable something. It is basically a list of a string, and then I can say that something is basically a list of string. So is the other way around actually. And actually the first thing that I need to do is say that this is a list of a string, and then I am appending a new thing, and then I can just do something like fprintf or something. So import fmt dot f, then printf, and I can just say this is the value, and I can just say like that something at 0 and then 0, and then go run build. What is the fucking help? Go run, I guess. Yes, actually, I forgot new line. Go run. So yeah. Now in addition to that, what I want to do is say that we have something like type scope is basically a list of string, and we can just say that this is a scope. Then we are initializing this, which is basically the same thing and should work just fine. In fact, it does. Okay. Now, let's say that we have a struct that is called another, and it has a scope, and it is a list of scopes. And now instead of having something like this, we have another as another in here, and we are saying that we have a scope like this. So instead of something now, we have another, same as here. And that should also work. Yeah, so another dot scope. Yeah, it's uppercase, I guess. Invalid operation. Why is it invalid? Because it's a scope. Sure. It is still fucking working. Now, if I say this is a pointer, because I am dereferencing, it is working. And after that, I'm getting this another dot scope at a given position 0, and I am assigning it to something. and then I want to print something. What? Why? What's this? It should print twice. Sure. Now, this something I want to change it at position 2, whatever. I am saying it is equal to 0. And then I want to print it again. Yeah, that's annoying because this is not working. Isn't it a slice? Can I not change it? Isn't it a slice that I can just access? Huh? Sorry, I need to do it like this. Yeah, not something actually. I want to change it in here. I want this to be the thing that I want to change actually. So paste this and then 0. Yeah, it works. Because something is a pointer to that thing. Therefore, it is working. Then why it wasn't before? I have no fucking clue. I don't know. Is it a me issue? A skill issue, I guess? It's a skill issue from me? Type inference. Sure. Because that's exactly what I'm doing right now. I get that as a pointer. I use that for checks. Because it is a pointer, I am assigning things to it. And it is working. Should I be passing things as a pointer as well in here? Probably, I guess. So if I go back to chaos and then I need to basically pass this as a pointer. Now it should work, I guess. So fuck this. That is annoying as fuck because now I can't do that. It is super weird that I cannot go through a range using a reference. Like, can I do this? No, I can't. Can I do it like this? No, I can't. Can I do it like this? No. I cannot pass a reference as an iterable, I guess. but this should work as well. What do we get? Sorry, no, fuck this. Grab. Line 28. Yes. Just delete this. So it is in fact working here. But later it doesn't, for whatever reason. And then we need to consume. That's something that I forgot, I guess. And then I need to do the same thing in here. And instead of S64, this is a string and this is a boolean. And now it should be fine. Maybe I don't think it is, because why would it be fine? It wasn't working before, now it's still not working. So let's go into here, and I want to basically chaos debug the program. Yeah, but this needs to be the data. So value 4, there's nothing. Value 1, also nothing, because fuck me. But it is in here, we can see clearly it is in here. And what is the actual fucking scope? It is fucking duplicated for whatever fucking reason. Value 1 is S64. Value 1 is S64. And value 4 is value 1. But it doesn't show the type. Why though? Why? Yeah, this is driving me kind of crazy. Probably later I need to debug this, but I don't really feel like doing this right now. Yes. Kind of annoying actually. We are checking the correct thing. No. It is not even here the problem. The problem is here in the inference. do I have before nothing and after something? Okay. In addition, I want to do the program.data. I want to know before and after, and I want the number one thing. Type 64 before nothing. It is in fact working. It is fucking working. Now let's look into the scope. Zero position, because this is the only thing that matters right now. So S64 before nothing. So it is in fact working. Not going crazy, not going crazy. But after, who knows? Who knows? Who knows? Chaos debug. I want this right here. Sure. What is this? Sorry. Var declaration. Why is it so big? Huh? Sorry. No, it shouldn't be that big. Yeah, I know why. So variable declaration for instead of this I want to print this. Why is no? What is this? What? Huh? It is value for what? Oh, is that a problem? So we need, if that is the problem and I've been doing this wrong this entire time, I will just assignment dot var declaration dot name dot symbol, and we actually need this instead of the other fucking thing. Left hand side. Sure. Oh no. Yes. Now it is fucking working because I was using the wrong thing. 2 hours to make this. Not even 2 hours, 1 hour and something to make this fucking work. To make this work again. Which begs the question now, can I just enable this and it is what? No. And if that just works. I guess. Let me uncomment this. Yeah, okay. That just works. So if I then do something like new value 1, or I mean 2, and this is the 1, and I say this is a string, whatever, and I can just say this is value 2, and then I can say new value 3 is a boolean, and this is value 3. That should work. Okay. I guess it just works, and it was a skill issue. So, yep. Okay. So if I go back to type checking, now it is in fact working. This works for string literals, for numbers. I don't have it for booleans, I guess. So let's do this first for booleans, which should be straightforward, I guess, because it's copy and paste. Node boolean. So this is a boolean. We are casting this to boolean, and this is bool. And this should be like B, I don't remember, it's T. Is it T? I don't remember what is like. So Golang fmt print for boolean. It's T. Okay. So now I can just do this, and it is supposed to work, sure. And if I try something different, instead of this I do this, it should fail, I guess. Expected boolean but got a string. Yeah. And if I do one, it expects boolean, but got whatever. Great. So it is in fact working. Now if I try to compile the main2, it should fail. Why? I think I know. If I go back to the type inference, this right here, the left hand side dot node type. So even before that, I need to say like this: var declaration, and then I need to say that node type is equal to node identifier. Otherwise, it's not a good thing. And now it should work. Sorry, what? I don't get the problem in here. What is the issue? So it's something here then. Okay, not there. Is it in here? Unexpected node call. What do you mean unexpected? Where is node call here? Here, I guess? That's what you're talking about. So the other thing that we can basically, if it is not node identifier, just move on. Why are you complaining about node call then? Type check 117. Okay, this is a completely different error then, because it's basically not handling calls. That's fine. Which is not a big deal. I can just say like whatever, and then that is okay. Yeah, that's cool actually. So something returns nothing, or I mean something returns a string, but we got whatever. Yeah, this is a weird error that I need to handle later, but I think for now that's okay. I will just commit what I have in here, and then tomorrow, maybe another day, I'll continue working on this because it's been almost 3 hours and I'm tired. So let's do this, and then main2, and then let's commit anything in here. So what do we have in here? So let's just push this to origin, which is basically, yes, no, I need to fixing type inference plus type checker. And that should be better now. I can take a look in here. So here we have it. Yeah, there's a bunch of changes in here. That's not important. So we are doing these two new operations. We removed a bunch of shit. We included some shit. We fixed a small bug, I guess. It's not even a bug, it's just weird. Included weird things for this, I guess. We fixed, yes, we are the returns. We included assertions. We are getting things by pointer now. Fixed a bunch of things. Yeah, okay, that sounds nice. Later I will work on this a little bit more, but for now that's good enough, I guess. But yeah, it was a good session. So thank you for watching, and see you later.